Hello students. In this video, I am going to discuss and illustrate on how are we going to work on with the derivatives or solving the derivatives applying the chain rule. As you can see here, the chain rule is a technique for differentiating composite functions. And talking about composite functions, these are made up of layers of functions inside of functions, just like peeling the onion. So the onion, you can see the outside surface of the onion representing, and it's just peel it away, and there's still more to peel to an onion, then some of the functions have many layers that must be peeled away in order to find their derivatives. So, in relation to chain rule, it's just like peeling out an onion that you need to work on with the outside function and its inside function. Just like, for example, y is equal to f of g of x. In order to identify, the g of x represents as the inside function, and our our f there is our outside function. And to continue, dy over dx is just simply equal to, or solving its derivative, it's just simply the derivative of the outside function multiplied to the derivative of the inside function. If y is equal to f of g of x, then dy over dx, or its derivative, it's equal to f prime of g of x times g prime of x. For solving a certain function applying the chain rule, we need to follow three steps. First is to identify inner and outer functions. Second is derive outer function first, leaving the inner function alone. And lastly, derive the inner function. And of course, we need to operate and simplify our final answer. Let's start here with our first example. The given is y is equal to the quantity x squared plus 3 quantity cube. The inside function there is our x squared plus 1. If the inside function contains something other than plain old x, you must use the chain rule to find the derivative. And y is equal to the quantity cube is considered as our outside function. So to continue, how do we work on with its derivative? Applying the chain rule, dy over dx, or its derivative, is simply equal to 3 because that's derivative of the outside. And if you might be asked, where did we get the 3 there? That's the value of our n here. The n is equal to 3. To continue, since we are applying the power rule, you need to take note that 3 minus 1 is equal to 2. That's deriving the outside function alone. Then following the rule and the step itself, that we simply copy our inside function there, and that's going to be x squared plus 1 inside times 2x. So if you're wondering where did I get 2x, that is the derivative of x squared plus 1. Take note that the derivative of x squared is 2 times x to the power of 2 minus 1 plus 0, since the derivative of 1 is 0. And therefore, to simplify that, that is equal to 2x, and that's the reason 2x is located there. And to continue, we need to, uh, there in the label, that's the derivative of the outside and then the derivative of the inside. As you can see, how did we get 6x there? That's simply multiplying the 3 to the expression 2x. If you wanted to clarify if you can expand it first, then multiply the 3, yes, you can do that. Or you can expand this expression and multiply it to 2x, yes, you can still do that because a multiplication operation is just commutative. And to work on, if you might be thinking, is this the final answer? Not yet, because you need to expand first your x squared plus 1 quantity squared, which is simply equal to, let me copy the 6x there, and then if you expand that one, that is x to the power of 4 plus 2x squared plus 1, and that is the expanded form of that binomial square. Then lastly, we need to distribute 6x to that expression there. So that's going to be 6x x times x to the power of 4, that's equal to 6x raised to the power of 5. 6x multiplied to 2x squared, that's plus 12x cubed. Then 6x times 1 is just 6x. So for our final answer, or the derivative of that function, that's going to be 6x raised to the power of 5 plus 12x cubed plus 6x. And we cannot simplify that anymore. That's already in its simplest form. Let's continue with the next example. So for the next example, that's going to be f of x, which is equal to the quantity 6x raised to the power of 4 minus 2x squared plus 3 quantity 1/3, or the exponent there is 1/3. So just the same process, applying the chain rule, we need to take note that we have an inside function there and we also have our outside function here. And let's work on with this function, solving for its derivative. That's going to be f prime of x, which is equal to 1/3. 1/3 represents the value of n, applying the power rule. And then you need to take note that 1/3 minus 1 also, since we are applying power rule here, 1 over 3 minus 1, the answer there is a negative 2/3. And that's why the exponent here is already negative 2/3. Then copy the inner function. Next is multiply it by the derivative of the inner function. The derivative of the inner function is just simply 24x cubed minus 4x. So to show you there the solution, why it become like that, it's just simply 6 times 4 as the value of n times x raised to the power of 4 minus 1 minus 2, applying the power rule again, times 2, then x raised to the power of 2 minus 1. I don't need to write the derivative of 3 since the derivative of a constant will always be 0. And to work on with its simplification, 6 times 4 is 24. 4 minus 1 is 3 and the exponent, then 2, negative 2 times positive 2, that's negative 4. The exponent, 2 minus 1 there, is 1, therefore that's going to be x alone, then we're not going to write 0 anymore. To continue, we just simply rewrite and bring down 1/3 at the same time the inner, and you may factor out their common factor in this expression, which is 4x as its common factor. Then the remaining expression after you factor out the 4x, that's going to be 6x squared minus 1. And to continue, that's going to be 4 over 3x. Then just simply copy that expression with the negative 2/3 as an exponent, and 6x squared minus 1. And lastly, as you can see that there is a negative exponent, we need to bring it down to the denominator. And here in the final answer, that's 4x times the quantity of 6x squared minus 1 all over 3 times the quantity of 6x to the power of 4 minus 2x squared plus 3 to the quantity raised to the power of 2/3. Or if you were not able to factor out, that's still going to be equal to 24x cubed minus 4x all over the same denominator, or you can express that into its radical form, which is the cube root of, I'm so sorry with my handwriting, that's going to be 6x 4 minus 2x squared plus 3 raised to the power of 2. So both answers, which is this one and this one, is considered correct. So let's have our third example here. In the third example, the given is f of x, which is equal to the quantity 3x minus 2x raised to the power of 4, quantity raised to the power of 6. We are still going to apply here the chain rule where f prime of x is simply equal to 6. 6 represents as the value of n applying the power rule. Then 6 minus 1 is going to be 5 there in the exponent, and copy our inner function, which is stated in the second step. And we derive our inner function next. So the derivation for that, derivation of 3x is 3. The derivation of 2x raised to the power of 4 is 8x to the power of 3. To show you the solution, that's going to be 2 times 4 raised to the power x times x raised to the power of 4 minus 1, and that's the reason there's 8, and then 4 minus 1 is 3 for the exponent. So let us continue. If you wanted to work on with that, you need to make sure that it's in the simplest form. We may distribute our 6 to this expression. And that's going to be 6 times 3 is 18. Then 6 times 8 is going to be 48. So minus 48. Copy your variable with the exponent. And that's our expression there. Multiplied to the expression 3x minus 24. I mean 2x raised to the power of 4 raised to the power of 5. So you could have this one as your final answer. You don't need to expand that one because that's going to be quite long. So you may stop with this, and this is your final answer. How about if there is a radical symbol in our function? You need to take note and recall that a square root of n is just simply equal to n raised to the power of 1 half. Also, a cube root of n is equal to n raised to the power of 1/3. A cube root of n squared is equal to n raised to the power of 2/3. So I want you to recall that concept on how we convert a radical form into its exponential form. And to continue with our example, we started with deriving our outer function. 1 half represents as the n, then 1 half minus 1 is equal to negative 1 half. Copy our inner function, then multiply it to the derivative of our inner function. How did we get 6x minus 1? That's because 3 times 2 times x raised to the power of 2 minus 1 minus 1 plus 0. 3 times 2 there is 6. X raised to the power of 2 minus 1 is just simply x. Then copy minus 1. We don't need to write the 0. And after that, we need to work on with this operation. Make sure to distribute it carefully. 1 times this expression is just the expression alone, which is 6x minus 1. And as you can see there, our exponent here is a negative 1 half. In the final answer, as we simplify, we do not allow a negative exponent. Therefore, you are going to write 2 there in our denominator times this expression, and from negative 1 half, as we bring it down in the denominator, the negative 1 half will become positive 1 half. And this is already our final answer. Simple as that. We cannot simplify it anymore. And I wish you good luck for your quiz and your exam. Thank you so much for listening on my discussion and illustration or solving with chain rule as we derive functions. Have a great day.